So we are looking at some theoretical part of AI. Theoretical part, again, this is a theory class, so we are having that today, and I hope you followed what we did in the lab. And you have to practice. That is what is required. Okay, so a brief history of, not brief actually, the history of AI. You will be surprised to know that it actually evolved just even before our independence in 43. The concept, Warren McCullum and Walter Pitt got an idea that there can be artificial neurons, or there can be something like intelligence which can be manufactured, created. Okay. Then in 49 we had development. Year 1950 again we have some more. Then in 52, 56 there was some more development. We had something like ELISA, and we had the first bot also. Robots were developed by Japanese. Then there was an AI winter between 74 and 1980. When we say AI winter, or winter in that case, the government agencies or the investors are not very much interested in financing a project, something like AI. Right? So that is where we have two winters actually of AI, where there was not much interest by the government, and they were not interested in financing, supporting AI. Maybe because of some financial crisis, or maybe because there was nothing much in hand at that time. Although Lisp, COBOL, Fortran, these languages had come, Lisp was the first object-oriented language which came up in 56, between 56 and 74, you can say, but it was 56, I believe. Things were there, but still miles to go. So in 1887, there was a boom of AI. We had expert systems that time, and these expert system actually we are using these days also. They are like more used by the medical people, medical science, by the doctors, by the scientists. What they do is they put a bunch of questions with answers, possible answers. Like if you have this symptom, then what the cure could be, or what the medication could be. So even today, if you go to some homeopathic doctor, the doctors would be asking you about your ailment, about your symptoms. They will be feeding that, and they will come out with some solution. And even if you go to Ayurveda, like we have Patanjali stores where the doctors are there, and even there, if you give your symptoms, you tell them, "Ki what is what is happening." They will be asking few questions. They will be taking your reports, feeding the reports, and finally there will be a solution which will come out, and that is an expert system. Actually, there is not much intervention by the doctors there. They know what the medicine is and what the medicine is for. So if something comes up and which you think will not be suitable for the patient you have, they will just ignore that, but the solution will come out. So you will have some solutions there of the medicines. So expert systems, the work in the medical field, like no, I have seen it working, and other system we have developed expert system also. I have worked on expert system in 91. Yeah, in 91, 91. Yeah, in 91 I worked on expert system, developed some uh, because that was a time when they were coming up. So I was learning that those days. So I developed a little bit, saw a little bit of that, to how it works. But it is interesting, and still a lot more to be done there. And now we have the bots, which are actually kind of your expert system only. You feed in some request, and they will fetch the possible solution, like FAQs you have. So if you digitize FAQs, then you will get the expert opinion, and that is why they are called expert systems. And more or less it is correct. Sometimes it may not be. Like since I knew how expert system works, so I confused my homeopath doctor, and she tried a lot, but she landed up always with 400 or 200 solutions. So I confused her because I knew how it worked. So I wanted her to examine and tell, but she was using the system. So I said, okay, fine, use it. I'll confuse it. Simple. So I confused it. But that is not to be done. Anyway, I was just testing that. That is why I told her later that you were trying to do this with me, and I already know expert system how it works, so I confused it, and that is what I wanted to tell, that it can be confused. So don't rely too much on that. That was long time back. So these days we have better systems and better things as we have more data. It is like suppose you have COVID helpline. Now we know that earlier in the first stage when I saw the COVID virus, which came from Wuhan, China, and the origination, and the data was also available there only. So that is why I would say that it originated from there. But the data I can say definitely originated from Wuhan, China, and there was a lot of data where we could see how the virus was designed or works, or not designed, rather it is, if it is natural, it can be natural also, but how the architecture was, and how the sequencing was, and everything was available, and the data of the patients was available. So if I use that data, and if I keep on training it, and we have seen the worst wave in our life, that is the second wave, where it was just out of control, and deaths were like anything because of lack of intelligence we had, and the confusions which created. And there were a lot of WhatsApp graduates and postgraduates who tried to cure themselves at home, and just we were scared to go to hospital or consulting in a doctor. But we had some expert systems there also, and they came up on WhatsApp also, and social medias like Facebook also. Some expert systems were developed, but they were like in the first wave we were having different symptoms, and in the second it was little different, and that created a little confusion. But now if we say, see, we have the two waves and two different variants. We have more than 100 variants of COVID. So if we see that, so now we can develop a better system, and that is there already now. So expert systems are there, and Python also has worked on it, and we have some expert systems there also, and we have a module. It is called COVID BERT. COVID BERT is there, so that can also be helpful. It can tell you something, few things, and can detect few things out of that also. But not although it is not for medications, but it can be for the signs, symptoms, and I have my paper also on COVID, that is to detect early detection of COVID through X-rays, and that went to WHO. We are still waiting for the approval. It takes time. That is what the problem is, but it is there. So earlier detection of things is possible. So that everything depends on data basically. When we are designing an expert system, so everything depends on the data, right? So in 1980 it came up, and I did it in 91. So that was 11 years after that, but it was fun doing it. Okay, so but that was the time it started developing. Then we have I expert systems in 80. Second winter was there in 87, 93. Again, not much of interest by shown by the government agencies and the funding agencies. So that was the time when they were not much interested, and it happens. The people are not keen to invest on something which they are not sure of, right? Now, 1 minute, I was just trying to correct something. The second winter, yeah, this went actually up. No, it's okay, right? So we had another slump time. Second winter was there between 87 and 93, and then the emergence of intelligent agents started in 93, 9, and 2011. This is where IBM developed Deep Blue, uh, chess champion, and which actually defeated Gary Kasparov also once. Not always, but yes, we had Deep Blue chess system, and then we'll come to that later. Then we had vacuum cleaner AI based in 2002, and it just started actually coming up in your social media also, Facebook, Twitter, Netflix. Then deep learning data, everything is started in 2011. A lot of presentations and all were there, and a lot of development was there. And we had the chatbots, Eugen Postman in 2014. Then we have the having the which was having the famous Turing test, and then we have the debaters, then duplex, that is Google demonstrated duplex, which was a virtual assistant, and it's going on actually. So from 2011 till present, so it is like a boom, and people are just crazy about AI. It can do wonders, but AI is just have to remember they are machines. You have to remember that they are machines. You have to program them, otherwise you will get garbage only. It is what the thing is, garbage in, garbage out. That is what computer works on. So you don't provide it proper data, you can you won't get the desired results. It is as simple as that. That is just a brief history. So you should know that it is something which is very interesting from 43 till date, and it is growing, growing, and growing, and demand is there in every field. It is not that it is limited to IT or CS. It is in electronics, it is in electrical. We have a lot of smart things there. Then in manufacturing also, AI has taken its place, and it is, robots are there, then smart machines are there. Everything is coming up, and it will be developing further also. It is not an end, it is just a beginning, I say. And we have miles to go still, because still human intelligence is better than AI. So, but it is very close now, since the development of emotion recognition. So things have changed over the years. So now it can think, it can feel, it can act according to the mood of the person, and it is very helpful in case of detecting if you want to find a criminal, or if you want to find the status of a person, how the person is thinking. And interestingly, recently I was studying something, and we were thinking of working on it. And as I told you, I think earlier also, that if you think of something, then the other person would also be thinking like that. There are 5 6 people also thinking like you, and the one who implements first actually scores. So that is what happens. And we were also thinking of something like AI in education, but yeah, it has been implemented, but miles to go again there. It is like we have some providers, education providers like Vedantu, which is using AI. They read the face of the student, mood of the student, how the student is feeling, and accordingly, or how the student is following the syllabus, and accordingly, they design or they manipulate the syllabus looking at the interest. But we normally don't have the videos. People switch off their videos because they have to do a lot of other work while attending the classes, and some of them sleep also with their headphones on, or just for the sake of attendance they will just come and go, right? So they just log in. But uh, but whoever is logged in and with a video on, and Vedantu may be having some sessions where it would be compulsory for the students to switch on their videos. So if the video is on, or even if I have an image, I can definitely get the emotion out of it. Not a big deal. And I can show you also someday that how I can get the emotions out of from the face, or from the voice, or from the sound, or from the videos, whatever it is, right? So we can do that. That is not a big deal. And we have one of my student has a patent also on that. That is to recognize the mood of the person in public place, like a criminal, detecting a criminal, intent of criminal, activity of a criminal, and something like that. So we have done that also. So it's not a big deal, but yes, it requires a lot of computations. It is interesting field. AI is very interesting field. If you get into it, you will understand that how interesting the field is, and where all you can implement it. You just think, and you can implement, right? Like, who thought that you will have a robot which can clean the house on its own? It will just move around with the small gadget will just vacuum your house, right? Clean your house, and you just sit and just let it work. Although it is a very costly machine, because market depends on the demand and supply, although there is nothing much in there. And but they are workable machines. Like, we have now drones also. So if you look at the drones, and you'll be looking at the Republic Day parade, not Republic Day, it is beating retreat. I think we will be having 1,000 drones of IIT Delhi or Mumbai, with their startup. And there's a startup, because all the IITs I know, they have the startup thing, and they promote startups, the finance and all, everything is available, the place is available. So they provide the place, and the students get financiers, investors, and they have the projects. They tell the project, okay, this is the project I have, and you get the investors who would be interested in investing. And since it is an IIT, ISC Bangalore, IITs, and NITs also. In NITs also, some places will find this, and some private engineering colleges also. I'm not sure about Symbiosis, but there is a place. There's whole investment there for the startups in many colleges now, many universities now. They're promoting the startups, and they're doing wonders. They're doing wonders, I can tell you. And a lot of new things are developed. Like, earlier, we just used to think that this can be done, but where are the finances? But now, if you think, then the finances are available. You just have to hunt them, convince them, okay, this is my project, and you find that. So when we were talking about the drones also are interesting, and they can be AI based. They can recognize the people, they can recognize the traffic, they can recognize the criminals in the crowd. Image processing is there, and it will be very helpful in future. It will be very difficult for the criminals to run away if we apply AI properly in these machines, these drones, right? Okay, image, capture the image and detect. Because we did in a lot of time, it was 2016, I think. We did recognize the faces in the crowd. So if it is possible to recognize the faces in the crowd, it is very much possible to recognize the criminals in the crowd also, right? The only problem today is everybody is wearing a mask. How to detect the person? So that can be worked out. You can detect from the features, from the appearance of the person. So you can do that from the eyes, but you don't have the retina scan. Definitely cannot. But the eyes, the forehead, the hair, everything is there visible. Whatever is visible, you can detect. You can predict the person can be there. Then the local police can always check. So manufacturing actually would be very very smart in the coming future, and this field develops so fast that while I'm saying something, something new would come up, right? Even when we are having a lecture, we are having a class, someone would be working on a new project, a new idea, and maybe implementing also. And thanks to the languages and the platforms like Python, R, and MATLAB, that things are very very fast these days. You don't have to code thousands of lines just to display an image, and like we did used to do in C. You have to write thousands of lines to display a single image, and if you have to move it, it would take more time and more efforts. But you don't have to do anything like that. Single line of code and things are done. So you don't waste time on the basic things these days. So AI would help you to develop your things, and the platforms are there, modules are there. Then we have some tools which are there. BI tools also are there for business intelligence. Like you just need the tool, put the data, and the output will be there, right? So the history is good, and the future is better, right? So let's come back now to some more theory. This theory, I try to make it interesting, although personally I don't like theory. And, but anyway, now types of AI. You have to understand this also. To understand the capability of anything, you should know a little bit about it also. Little bit of everything is required as far as 1 minute. I'll just copy it, then I'll tell you. Okay. 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 I hope I'll be sharing the PDF also and this also, so it is not an issue. I just want to see whether it is working or not. Okay. Now this is fine. Let me share the text. Okay. Now just tell you something. Okay. So why we require the theory to understand the capabilities? Okay. So that is what you have to do anyway. So types of machines, we have four types actually. One is the reactive machines. These reactive machines are basically fundamental. They are guided by the fundamental AI principles, right? That is, they react to the environment. You can say that is why they are called reactive machines, right? So, with an example, I'll explain it. Like we had just now told you about Deep Blue. That is a supercomputer of designed by IBM, which could play chess and which actually defeated Gary Kasparov also. And those who are interested in chess, they would be knowing who Gary Kasparov is, and how powerful this person was in chess. Almost undefeatable. He could not be defeated easily, and he defeated most of the computers. So they designed Deep Blue, and it could defeat Gary, but but Gary again reverted. It defeated the computer. So we have Vishnath Anand in India, who also competed with some supercomputers, and he was successful in some cases. In some cases, he lost. That is what the game is all about. You win some, you lose some. So that is okay. Losing is not a thing. Losing is learning. So I always say, if you lose, you learn a lot. Losing is not an issue. and failing is also not an issue. You learn from your failures, and that is how you develop your intelligence. Okay. Anyway, so Gary Kasparov was defeated by Deep Blue, but the only problem with this, because it is a reactive machine, it could only recognize the chess board and the pawns it has. Okay, and the moves, definitely if you move the pawn, so it knows where it is going, and if you move, if the other player moves, then it also knows where the thing is moving. So it could only recognize that. So that was the limitation of Deep Blue. Then we have AlphaGo from Google. That is another playing reactive computer, but also it is not able to predict the future. Okay, it actually relies only on its neural network, which is already feeded in, and it can develop only on that. It can work on that only. So if something beyond the intelligence of the computer, someone does that, so it won't be able to actually detect what is happening. It may crash, right? So it may not be able to work that way. It happens sometimes. Okay, so we had Google's AlphaGo, and uh, so we have some champions there also, and that is Reactive machine reacts the environment, what it sees, it reacts to that. But although it works on neural networks, most of the time you'll find neural networks working in AI, and these neural networks actually, the theory, or you can say, depends on the neurons, the structure, the neural structure of the brain, how the neurons work, how the neurons pass on the information, how they're connected, and network also works like that only. So it trains, takes the weights, and does things. And we have different type of neural networks, like we have recursive neural networks, also RNN, which are more common now, although they evolved a lot of time back, but they are more common and they're more used now. RNNs, recursive neural network, because they have the capability of storing in the memory, and then they can actually work on that. So they are not actually only reactive machines, they can think also. Okay, then we have something like limited memory. This is the second one, but that's okay. Now, so this is where things are working these days. This is the second, but this is what is at present also. So they can gather the information, and it can store what happened, work on and learn from there, work on that. Okay, so let me come back now. It has more capabilities and possibilities than the reactive machines, although limited memory is there, but it stores the facts, can forecast while gathering the information and evaluate potential solutions. It can predict also, uh, and it can peek into the future. That is what I said. It can predict also. Okay, so we have better possibilities with limited memory systems, more much better than what we had with the reactor machines. Okay, so we have three primary machine learning methods that use artificial intelligence with limited memory. One is reinforcement learning, which works on trial and error, like we always do. We try something, we get some errors, we correct those errors, then we try again. So it is like trial and error thing, reinforcement learning. And again, this is very interesting. Then we have long short term memory, LSTM. If you look at some papers, research papers of recent years, you will find that before 2020 or even 21 also, 22 you'll find something else, but mid 21 you'll find a few other things developing. But most of the papers, lots of papers are on LSTM. People, this is actually an example of RNN only. That is what I was telling you, recursive neural network. It is an enhanced version of LSTM. The beauty of LSTM is it has a forget gate. Okay, so it is bidirectional. Learning is bidirectional. That means it goes forward, comes back, learns, then goes forward, comes back, learns, and keeps on doing that till it is fully trained, and then it can predict also, right? It can predict, it can tell you what is happening, what is to happen. So prediction is very good with LSTM. And when I told you about the forget get, we'll be doing this in detail. I'm just giving an introduction of LSTM because it is something which is very very important these days. And although we have other things also, but LSTM is very simple to implement. And it and as I told you, it has a forget gate. That means something which is not required. You think the system thinks that okay, it is irrelevant, it will not actually just remove it, which happens with most of the recursive neural networks or neural networks. They will just discard something which it thinks that it is not important. Okay, fine, let it be. But it doesn't. It keeps it in a forget gate. And once it trains, it comes back, checks with the forget gate. Is there something important which is related with what I have learned now? It tells you, okay, fine, this is something important. It will pick it from there and then it will move forward. So it has a forget gate, which is very important part of LSTM or AI, you can say. Okay, so these are deep learning algorithms, not machine learning algorithms. We'll come to the algorithms later. So we have LSTM, reinforcement learning, and then we have evolutionary generative adversarial network, EGAN. This is again very important coming up. And uh, it can decisions, new decisions it can take. It involves allow to explore like and change courses if something changes. It can understand also uh, from its experience, from prior experience it has. And it has a mutation cycle. This model is always looking for a better path and uses stimulations and statistics or chance to participate outcome. So it actually learns from the past also, right? So this is something now ahead of LSTM, step forward of LSTM. We have EGAN and we have others also these days which are coming up. And since uh, your deep learning is now moving towards the transformers. So we have little development as far as deep learning is concerned, but these are still some new things which have come up. And we'll be seeing that in detail later. But this is just an introduction of what it is. And then comes your third type of AI, which is your theory of mind. Okay, so I'll just put it there. And these are things which are not developed yet. These first two are there now, but theory of mind is in very initial stage. So let me put it. I'll share the PDF later. And it's just a theory basically. Nothing has been developed yet. The idea of simulating the brain basically, how to simulate the brain, feelings and all influences, own reactions, how it is influenced and all. So it is more on theory now, but things have developed a little bit, not much, as far as theory of mind is concerned. Okay, so how people understands animals, how they react, how the machines feel, or how the people feel, then how the machine would feel, and what emotions one would have with the animals and all. It is more based on emotions, as I told you earlier. Also, once we have emotional machines, the machines having emotions, they will be better, and we can work better with them, because they will be very close to human intelligence in that case. And that is what things are working. And it is, although it is a theory of mind, how the mind works, and the development is there, and we will be seeing few things very soon. And if you have seen Pranav Mistri's virtual reality videos, you will be amazed to see that with just your fingers you can do wonders. You don't need a camera, you don't need to carry your laptops, you don't have to carry anything. You just have a paper, you can play a game on a paper. Virtual reality is amazing. So you can always have a look at the videos of Pranav Mistry and see how beautiful AI or virtual reality is. I can share the link if you want, or I'll share it, and you can have a look at the development he has done, and what he has done for the virtual reality and the future of AI. Although he did it a long time back, and things are changing, things are evolving, but developing things will be little difficult, or not like we need a compact system for that. What he would carry was a helmet with a camera and the sensors, which would be connected with a net always, and he was carrying that. Now he has put it in his neck, and he carries that with him, and he doesn't need any other assistance. But there is a scanner there, there is a connection with the net always, and his system is always connected with the internet, and more or less like Google, it is connected with that. But you're carrying something, and it has to be more compact. If you want it to be used commercially by the people, then it has to be more compact. Although it is a small thing now, but still things have to go. So I'll share the videos of Pranav Mistry with you, and you can have a look and enjoy that also. So I'll just share the link, and now comes the fourth one, and that is called self-awareness. And we have to work on this again. Okay, self-awareness. That is the final stage of AI. This is the final stage where we have to be. That is our future. That is what we have in mind always, to develop something like human beings. So human intelligence is self-awareness. You are aware what is happening, and your mind, theory of mind in artificial intelligence has to be clubbed, like everything has to be clubbed together to come close to human intelligence, and it may be more powerful than human intelligence, and the predictions that it can be fatal also. Nostradamus said that robots may destroy the earth someday, although he was born thousands of years back, but not thousands of years. It was 1500 something. So He was born a long time back, you can say. So he could see the robots or some machines working, intelligent machines working, and he could see the future until these robots may destroy the earth one day, and they may get out of control, and they may simply destroy everything if they are not controlled properly or not programmed properly, and if they are able to think on their own. And what if they think that, okay, fine, let's survive, let the human being die, why should we keep the human being, and we can enjoy our life better without the control of anyone. So it may happen, but not in near future. So we are not having that issue as of now, but it is possible that in future robots may, like we have seen a lot of English movies where robots are taken over, and that is possible. In South Indian movies also, I was lot watching one movie of Rajnikant. There also it happened like robots were just capturing everything. They were controlling everything. They were mutating like anything. They were reproducing like anything. But that is actually a movie. But a possibility is always there. Like we had a movie of the virus also, COVID, and you can see that how it is there. So it just spread. So things which come in mind may sometime come true also. Okay, so we have few things more to do, but if I take it, let me see, I'll continue it, but that's okay. I'm not able to complete now. I'll take it in the next class on Friday, but I want to show you implementations. I just want to finish up with this thing. Okay, anyway, it doesn't matter. We have a lot of time to complete the course. Okay. We have different type of learnings. We have a supervised, semi-supervised, unsupervised. A lot of things are there. Okay. So here the machine learns by example. Examples are सीखती है, and this is you have an operator. You have a you have a teacher who tells you if this has to be done, and the person, the supervisor, helps you in learning. A supervised learning is like that. Okay, and we have here classification, regression, and forecasting. These are the three types we have. Classification is like if you are looking at some images, I had given you an example of a furniture in a office, in an office, or in a house. So furniture can be classified like that, or in a showroom also, like spam mails, you can classify that also. So classify is putting things which are related to each other in one place. It is like classification is like putting your books in a library in proper shelf. Okay. So if you look at library, and library, the books are arranged according to the subject. So classification is arranging things together. Okay. Then we have regression, that is estimation and understanding the relationship among the variables. So regression is another technique. Future predictions and all we can do, forecasting we can do using regression. Then we have forecasting also, which is again a process of making future decisions or predictions, you can say. So supervised learning, we have three things, that is classification, regression, and forecasting. Okay. Then we have semi-supervised learning. As the name suggests, this is semi, that is only part of it is governed, ruled, or you can say managed by us, and rest it learns on its own. In first case, when you were saying supervised learning, I have to tell the class of the act. Like if a person is fighting, I have some videos of boxing, and I have some videos of fighting. So I have to classify by fighting and boxing, although they look same, right? And someone is walking slowly, someone is walking briskly. So I have to classify that. I have to tell this video is what. So the content of the video is like fast walks or slow walk, or it may be a fight, it may be running, it may be boxing, it may be anything, swimming also, cycling also. So I have to classify that. I have to tell the class in a supervised learning. In semi-supervised learning, that is actually reduced. So not everything has to be classified, told. Only a part of it can be told, right? And then we have unsupervised also. That is where we let the system learn on its own, and that is where actually we are heading to. This is what we are working these days. We normally use unsupervised learning, and we let the system learn on its own from the mistakes it may be making or from what it is doing. So we have two things here. Like we have a case of supervised, then we have clustering and the dimension reduction. Okay, 1 minute. That's okay. Okay, so it learns from the patterns. There's no answer key like we have the classes. There's no classes. There are no classes there. So we don't have any answer keys. That is, it doesn't know the whether it is the thing I have given is like the video is fighting or is just talking or running. It doesn't know that. It runs from the patterns. So we have here clustering and dimension reduction. Clustering involves grouping of sets. Similar entities go. It will just group up and find a pattern, and then it can predict. Okay, and dimension reduction is reducing the number of variables. You have to reduce the number of variables so that it can be faster and more accurate. What is relevant, only that is retained, and rest is removed. So that is what is to be done. Okay, then the last one, I can take this. Fortunately, this is where we are working now. But finally, reinforcement learning, but it is not necessary. The machine learning is actually supervised. Most of the algorithms are supervised. Okay, then we have unsupervised, semi-supervised. I'll give you the algorithms which are under what, and you can have a okay. So reinforcement learning, it focuses on learning, uh, regimented learning process. It's called a regimented learning process. We have machine learning algorithms. Actions are provided, parameters and end values are given, rows are defined, and that is how reinforcement works. It learns from the past experience. Okay, as we have seen in Illustrium also, we have feed forward and back propagation. Feed forward is just moving forward, and back propagation is going back, learning and going forward. And it depends. It just goes back only, and it is if it is bidirectional, it can move back also, forward also. It depends on that. So reinforcement learning actually begins. It learns from the past experience, and it actually tries to adapt it to the situation. Possible results. just tries to achieve the possible results from the past experience. So it learns from the past, and it predicts. So we have these four: supervised learning, semi-supervised learning, and unsupervised learning, and reinforcement learning. Right. So these are the things we have with AI, and I'll just stop the recording now because I'm not saying anything.